Hello everyone out there, this is Mr. Bradley. I'm going to be trying to make these videos as consistently as possible to keep us all still moving forward with chemistry. And I encourage you guys to send me messages and stay in contact as much as you can too. I look forward to hearing from you guys and keeping in touch, okay? So I'm going to try to use this as sort of a way to establish a template. I'm going to try to do the same kind of thing for each of these topics. All right. So this is a bit of a review because I think almost everybody was in school for topic 5.1. So I'm going to go through this. I know this topic was a little challenging, so I'm going to keep it kind of simple here. All right, and try to keep things as understandable as possible through the video. All right. So if you guys remember, we defined what the mole was in chemistry, all right? And a mole is a word we use to define a quantity of a substance, and that substance could be either an element or a compound. The quantity can be measured in a couple of different ways, or three different ways. Gram formula mass, 22.4 liters, or parts like molecules, and in that case we use Avogadro's number, 6.02 times 10 to the 23rd. But if you remember in class, we said that the one that we use most often is definitely going to be the GFM. So in a chemical equation like this one right here, we can use the idea of the mole to give quantity to all of the substances. The first substance, nitrogen, has a mass of 28 grams per mole, and so we understand where that comes from. If we look at our periodic table right here, nitrogen's mass is 14.0 because we round to the 10th place. And if we're looking at our formula, remember this is the gram formula mass, what I would do is I would say nitrogen equals 14.0 grams, right? But if you look up here at my formula, this is N2, right? And so that means that I am going to take the 14 and I'm going to say 14 times 2 equals, and that's where I get the GFM, which is 28 grams per mole. Gram formula mass always equals 1 mole. So if I want to know the mass of a mole for any substance, all I have to do is take the elements in the formula and use their masses to find the GFM. So in this case, it would be nitrogen's mass times 2. Right? If I take a look at the next substance, which is hydrogen, right? Hydrogen is H2, right? And so its GFM is 2. Now, again, where did that come from? If I look at my periodic table, hydrogen has a mass of 1. Oh, hang on, let's see if I can get that over here. There's hydrogen right there. 1.0 is the mass of hydrogen. So the way I would do this would be to say H equals 1.0 grams. How many hydrogens are in the formula? The formula is H2. So again, I multiply by 2. And that's why the GFM of hydrogen is 2 grams per mole. Remember that GFM is always equal to 1 mole, so the unit that I would say for GFM would be gram per mole, right? And the last substance in this equation right here is the ammonia, and the ammonia has a GFM of 17, right? So we can figure this out. We've already got the numbers here. I know that the ammonia is going to be a nitrogen, right, which is equal to 14.0 grams. I know that the ammonia has hydrogen, which is equal to 1.0 grams. However, it is H3, right? The formula for nitrogen is NH3. So I have to say 1 times 3 because remember, my GFM is all of the atoms summed together. So that means it's 3.0 grams. So what's my GFM for the formula NH3? Where'd the 17 come from that I see right here? Where'd that 17 come from? That 17 is my 14 and my 3 added together, right? So NH3 3 equals 17 grams per mole. All right, so this is the idea of the mole. And we saw in class that the mole is used to identify quantities. So if I look at, let me pull these away here. If I look at this, I can see here that right over here, I see that this one is telling me that I have 1 mole of nitrogen in the equation. So that means the GFM of 28 is the total mass of nitrogen. But here this 3 is telling me that I have 3 of the H2s. So 1 mole of H2 is 2 grams. That's the GFM that we calculated here, right? 2 grams per mole. But the 3's tell me I have 3 moles, so the total mass of the hydrogen, I'd say, all right, well, 1 mole is 2 grams, so 2 times 3, 6 total grams. Here, this number's telling me that I have 2 moles of the ammonia in the formula. We said that the GFM of ammonia is 17, and so that means 2 times 17 gives me 34 grams, right? And the cool thing is that when I use moles appropriately for the quantities in a chemical formula, both sides of the equation should have the exact same mass, right? So moles gives us quantity. All right, now, going further than we did the other day, what are the 3 constant values for moles? Okay, so remember, mole is quantity, and there's 3 ways that we measure it. The first way is called the gram formula mass, and this is the one that we will use by far the most often when we're talking about the concept of the mole. Okay, so gram formula mass is what we just did. It's the mass of all of the atoms of a substance added together. So for some examples here for you on your notes, guys, what is the GFM of water? All right, well, water has a formula H2O. So the way I determine the GFM of water is by taking the masses of the elements, which is what I've got right here, right? Hydrogen is a mass of 1. The formula is H2, so I have to say 1 times 2. Oxygen has a mass of 16. Remember, we're rounding to the 10th place, right? So it becomes 16. And there's only 1 of them, so I say 16 times 1. And then I take the 2 grams and the 16 grams, I add them together, and that gives me the GFM, which is the mass of 1 mole of water. Okay? All right. And come on, eraser. There we go. Got another example on your notes as well, guys, and that one is the sodium chloride. All right, so how do I know that sodium chloride's mass per mole is 58.5? Well, I just look at the individual elements. I've got sodium and I've got chlorine. I'll jump back over here for a second, guys. Here's my sodium, right? And sodium is 22.98977, but I'm going to round that to the 10th place, which just becomes a nice 23. So it's a nice round number 23. Chlorine's all the way over here, and the chlorine is 35.453, so that rounds to 35.5. Okay, and so the sodium with its mass of 23 is just going to be times 1. There's only 1 of them in the formula. Chlorine, same thing. And so all I have to do is add 23 plus 35.5, and there's my GFM for sodium chloride. Like I said, guys, the GFM is the one that we will use by far the most often in chemistry. So this is it right here. There are 2 other molar constants that we want to be familiar with, and I will ask you to use them, just not to the same extent or with the same amount of precision maybe as we do with gram formula mass. All right, so the next molar constant that we want to look at is the molar volume of a gas at STP. And so the idea here, guys, and we did look at this in class as well, but the idea here is that if you have 1 mole of a gas, the volume that the gas occupies at STP will always be 22.4 liters. And the great thing here is that it doesn't matter what gas it is. So 1 mole of carbon dioxide will have the exact same volume as 1 mole of nitrogen, as 1 mole of helium. And so we can use this number 22.4 as a constant the same way we did with GFM. The difference is I don't have to calculate it. It's always 22.4. So that's kind of neat. Okay, and then the last of the three molar constants is the one that is probably the hardest one to kind of wrap our heads around. We don't use it a whole lot, but it's Avogadro's number, and Avogadro's number is that huge number, 6.02 times 10 to the 23rd. Sorry, there the 23 here should be superscripted, right? It's 6.02 times 10 to the 23rd. All right, and that is referring to the number of units in a mole. So for this class, the mole is almost always talking about either atoms or molecules, right? So for example, if I'm just talking about an element like iron, well then I'd say, sorry there guys, I had a little interruption from my kids. So where I left off, I was saying the Avogadro's number is referring to how many atoms we have if we're looking at an element, or it could be how many molecules we have if we're talking about a molecule or a compound, right? So just as an example of what you might be asked to understand, let's say that I have 1 mole of the formula aluminum nitrate. That's AlNO3 parentheses 3. The way that I could interpret that would be to say, how many moles of aluminum are in the formula? Well, I'd have 1 mole of aluminum, right? That would be 1 mole of aluminum. But how many moles of nitrogen are contained in the formula aluminum nitrate? Well, nitrogen is inside the parentheses, which is multiplied by 3. So I would say that there are 3 moles of nitrogen in 1 mole of aluminum nitrate. And as far as nitrogen goes, oxygen has its own subscript 3, but then it's also inside the parentheses. Now that means it's being multiplied, so that means I have 9 moles of oxygen. Sorry about that. So to give you an analogy that I think works for me at least, I like to call this my mole donut, right? Here's my donut. And if I tell you that I have a dozen donuts, well, you know that means that there's 12 donuts, right? But this donut has sprinkles on it, okay? Every single one of these donuts has exactly 3 sprinkles, right? So if I ask you how many dozen sprinkles do you have if you have a dozen donuts, well, then you'd say 3 dozen sprinkles. Same idea here. If I have 1 mole of this, the atoms are the sprinkles on the compound, right? So how many moles of oxygen sprinkles do I have on this whole compound? 9. Okay, so let me wrap up with a couple of last things here from this note page. You've got this here on your notes, and the purpose of this is to try to understand that if we know that 1 mole always equals GFM, right? And 1 mole always equals 22.4 liters of a gas. That's this right here. And finally, 1 mole always equals Avogadro's number, which is the 6.02 times 10 to the 23rd. If all of these numbers equal 1 mole, then the connection you want to make is that all of these numbers also equal each other. So if I have 44 grams of carbon dioxide, which is its GFM, then I also know that I've got 22.4 liters of carbon dioxide. So I know the mass and I know the volume. And if I asked you how many molecules of carbon dioxide are there in 44 grams, again, you know 44 grams equals 1 mole, so you know that you have this many molecules. So these 3 numbers are not only equal to 1 mole, but they're also equal to each other, right? And so if I was to say double that, what if I said I don't have 44 grams, but I have 88 grams? Well, that equals 2 moles, right? So that means I would have 44.8 liters, and that means that I would have 12 or 0.02 times 10 to the 23rd, or in proper scientific notation, 1.2 times 10 to the 24th. Okay, so that's an important connection for us with the mole concept. Again, GFM is the one that we use the most, but the other 2, we want to understand them. All right, and then the last thing we have here, guys, on the notes is just another example of how we would understand moles inside of a chemical formula. This is that idea, again, of my donuts and my sprinkles, right? So if the donut is aluminum sulfate, right? That's the chemical formula. How many moles of oxygen, right? That means the oxygen would be the sprinkles on the donut, right? So if I have aluminum sulfate, 1 mole of aluminum sulfate, how many moles of oxygen do I have? Well, I see I've got a 4, and then the 3 is outside the parentheses, so that means I would have, what's 3 times 4? Yeah, 12, right? 12 moles of oxygen, okay? Over here, actually, let me get your attention right here for 1 second, guys. You see this? This is something that you probably haven't seen yet. That little dot, you may think that it means multiply, and that's what you want to do when you see it in math. But in chemistry, that little dot is used specifically with substances that trap water inside of their crystal structure. So the dot does not mean multiply. It just means that the water is trapped inside of the copper sulfate crystal. So don't multiply it. If anything, you want to think of it kind of as an addition sign because you're adding those two substances together, okay? So the question asks for how many moles of oxygen in the copper sulfate. So, well, let's see. I'd have to take into account the whole thing, which is going to be the 4 here. This 5 multiplies because now it's telling me that I have 5 waters, right? And so that would mean 4 plus 5 to give me the grand total of 9 moles of oxygen, okay? So guys, this video went a little longer than I wanted it to. It's going to be a work in progress, and I'm going to do my best to try to make them as efficient and to the point, because I know watching a video is not the same as being in class where we can communicate back and forth, okay? But please be in touch with me with any questions, and I will have another one of these videos for our next topic shortly, all right? So I hope everyone's doing well. I hope that you guys are able to make the most out of the situation and find some extra time with a family or extra time to explore some of the hobbies that you enjoy already. All right, so take care and be in touch soon. Bye-bye.